Now, this proves fascinating because it reveals a profound misunderstanding regarding what science genuinely represents. You understand, science isn't concerned with establishing what's feasible and infeasible. That's not science's purpose. Science's purpose is to determine what's more probable and what's less probable. And to accomplish that, you need to comprehend something about how the world actually functions. You need to comprehend nature's laws. So, allow me to inquire of you something. If intelligent life exists somewhere out there in the universe, and I consider it probably does, the universe is so immense and life emerged on Earth nearly as promptly as physics and chemistry laws permitted. If they exist, what would occur if they attempted to visit us? That's the inquiry, not whether they exist, but what would it require for them to arrive here? Now, this is where physics becomes a constraint. You understand, nature's laws aren't merely recommendations. They're not something you can negotiate with or circumvent. They apply everywhere to us here on Earth, to any aliens out there, to everything in the universe. And that's an extremely important point to comprehend, because once you accept physics laws, you're accepting some very serious limitations on what you can accomplish. Allow me to discuss space initially, because space represents the primary complication. The nearest star to us is approximately 4 light years distant. 4 light years. Do you understand what that signifies? It signifies that light, the fastest entity we understand, requires 4 years to travel from that star to here. Now, if you wanted to construct a spacecraft and journey to the nearest star and return, you encounter a complication immediately. You would have to travel at some significant fraction of light speed. Otherwise, the journey would require thousands of years. Now, who's going to construct a spacecraft that requires thousands of years? You might state, well, perhaps these aliens possess some technology we don't possess. They can figure out something we cannot. Okay, let's consider that. Let's consider what physics laws express about getting a spaceship to near light speed. Envision you want to accelerate a spacecraft from 0 to, say, half light speed merely to select a figure. Well, to accomplish that, you need fuel, and the fuel must perform work. It must accelerate the spaceship and everything within it. Now, an elegant formula exists in physics that informs us something about this: the relationship between energy and mass, E=mc squared. This represents one of the most significant discoveries about nature. It informs us that energy and mass are connected, and it informs us something else. When you convert energy into motion, the energy quantity you need is enormous. And here's the matter regarding rockets. A conventional rocket, a chemical rocket, must carry all its fuel with it. All of it. The fuel possesses mass, so you must accelerate the fuel as well as the spacecraft. So you need more fuel. Yet that fuel possesses mass too, so you need even more fuel. And suddenly you recognize that to get a spacecraft up to even a reasonable fraction of light speed utilizing a conventional rocket, you need a fuel quantity exceeding the entire visible universe's mass. That's not a metaphor. That's the actual calculation. Now you might state, okay, yet perhaps they possess a fusion engine. A nuclear fusion engine is considerably more efficient than a chemical engine. It can release far more energy per mass unit, so perhaps they're employing that. Okay, let's allow for that. Even with nuclear fusion, which is incredibly efficient, considerably more efficient than what we can accomplish here on Earth. Even with that, you still need more than 2,000 times the spaceship's mass and fuel merely to accelerate it to near light speed and then decelerate it upon arrival. 2,000 times. Do you comprehend what that signifies? That signifies if they possess a spacecraft the size of, say, a large structure, they would need 2,000 times that much mass and fuel. The fuel alone would resemble a small planet. And to move that mass quantity, you would need an energy quantity comparable to all the energy that all of humanity currently utilizes, all of it in one journey. Now, an advanced civilization might possess that energy available. I'm not stating it's impossible, yet I'm stating it's a very severe limitation, and that's what I intend when I state aliens are constrained by physics. They're limited by the identical laws that limit us. Allow me to consider this another way. Let's state a civilization exists out there. They're very advanced, considerably more advanced than us. They've determined how to harness their star's energy, perhaps even their entire solar system's energy, and they decide, let's journey to Earth. Let's observe what's occurring there. They construct a spaceship, an elegant spaceship, the finest engineering they can achieve, and they equip it with their finest fusion engines, and they accelerate toward Earth. And because they're intelligent, they figure out a method to reach half-light speed. Perhaps they've even determined how to harness some exotic physics that we don't yet comprehend. Yet they still must obey energy conservation. They still must follow thermodynamics laws. They cannot simply create energy. And with all that, the journey's energy cost is staggering. Now, when they arrive here, they want to decelerate. They don't want to merely zoom past Earth at half-light speed, so they must decelerate. And guess what? Deceleration requires the identical fuel and energy quantity as acceleration. So now we're discussing twice the energy quantity, twice as much fuel. The figures become even worse. And here's another aspect I want you to consider. If they're coming from, say, a star in the Vega or Sirius region, or any of the neighboring stars, they've already traveled 4 or more light years. 4 years of travel, even at half-light speed, and they needed to accelerate for part of that journey, coast through the middle, and decelerate at the end. The energy quantity we're discussing is nearly incomprehensible. It's the kind of energy that can reshape worlds. It's the kind of energy that can boil oceans. So now, I want to inquire of you something. If a civilization possessed that much energy, that much power, what would they do with it? Would they genuinely expend it on a sightseeing tour to Earth? Would they genuinely expend it to visit a species that's barely determined how to split the atom? Consider the mathematics of it. To make an interstellar trip feasible, you would need an incredibly powerful motivation to do it. And the motivation would have to be something that you couldn't accomplish at home, something that you couldn't accomplish with your own star or within your own planetary system. What would that be? Perhaps they want to conquer us. Perhaps they want our resources. Yet our resources are particularly exceptional. Iron and silicon and carbon and water. These materials are ubiquitous throughout the universe. You can locate them anywhere. Probably 1 million planets around neighboring stars exist possessing the identical resources that Earth possesses. Why journey all the way to Earth? Perhaps they want to study us. Perhaps they're interested in biology and how life functions. That's a possibility. Yet if that's true, they would dispatch small probes. Perhaps they would dispatch a radio message inquiring to visit. They certainly wouldn't dispatch crewed spacecraft. The energy cost would be excessive. Now, I want to discuss something else that troubles me about flying saucers, and that's the evidence itself. You understand, individuals claim to have observed flying saucers constantly. And when you examine these claims, you notice something very fascinating. Nearly everyone who observes a flying saucer observes something different. One person observes a round, flat object. Another person observes a gray haze. Another person observes delicate filament-like trails in the sky. All supposedly the identical event. All supposedly the identical event. Yet everyone describes it differently. Now that's very peculiar because if you're observing the identical physical object, even if the observers are at different angles or different distances, they should still observe roughly the identical thing. A disk is a disk. A light is a light, yet no, these objects are incredibly variable in appearance. Conversely, when something genuinely does visit Earth in a way we can measure and record, we observe consistency. When meteorites descend from space, they all appear like meteorites. When spacecraft enter the atmosphere, they all appear like spacecraft. A pattern exists, consistency exists. Yet flying saucer reports no consistency, which informs me something. It informs me that what individuals are observing aren't actual physical objects from space. It informs me that what individuals are observing are probably a combination of things. Perhaps some individuals are observing unusual meteorological phenomena. Perhaps some are observing sunlight reflections on clouds. Perhaps some individuals are observing aircraft at odd angles with unusual illumination. Perhaps some individuals are having subjective experiences that feel very genuine yet aren't actually observations of external physical objects. Interesting research actually exists on this. A phenomenon exists designated sleep paralysis, where individuals awaken yet they're paralyzed, and they experience very vivid sensations of alien presences, of being abducted, of being removed from their bodies. All of these are subjective experiences that feel completely genuine to the person experiencing them, yet they're not external events, they're neurological phenomena. So the inconsistency in flying saucer reports to me represents evidence against flying saucers, not evidence for them. Because if an alien spacecraft actually landed in your town, I would anticipate you describe it accurately. I would anticipate consistency across witnesses. I would anticipate physical evidence, and we don't observe those things. Allow me to return to the physics, though, because that's the genuine point. The point isn't whether I believe in flying saucers or not. The point is that physics laws impose severe limitations on what's feasible, and those limitations apply to everyone. They apply to us, and they apply to any aliens out there. Now, something exists designated the Fermi paradox. You might have encountered it. It's a straightforward question. If intelligent life exists in the universe, and if some of that life has become advanced enough to travel between stars, then where is everyone? The universe is billions of years old. Billions of galaxies exist, and each galaxy possesses billions of stars. The mathematics suggests that life should exist in numerous locations, and some of that life should have had billions of years to develop and to explore. So, where is everyone? Why haven't we detected any alien civilizations? Numerous potential answers to that question exist. Perhaps intelligent life is incredibly rare. Perhaps civilizations don't persist very long. Perhaps physical barriers to interstellar travel exist that even advanced civilizations cannot overcome. And that final one is fascinating because it returns to what I'm expressing about physics. You understand, the Fermi paradox is occasionally presented as a mystery, yet I don't consider it's a mystery at all. I consider the answer is fairly straightforward. And the answer is that the universe is immense and space is deep and physics laws impose severe limits on what you can accomplish. An alien civilization might be incredibly advanced. They might have resolved every engineering problem that we must resolve. They might have figured out technologies that we cannot even imagine. Yet they still must obey energy conservation. They still must obey thermodynamics laws. They still cannot travel faster than light speed, at least not with any known physics. And I'm unaware of any compelling reason to consider that light speed isn't the ultimate speed limit. So here's what I consider. I consider that an advanced civilization might exist somewhere out there in the universe. I consider it's actually probable given how immense the universe is and how much time has elapsed. Yet I also consider that the physical limitations on interstellar travel are so severe that that civilization is probably very far distant, thousands of light years distant, or perhaps they're in a different galaxy. And the cost of dispatching a spaceship here is so high that they would never do it. They might dispatch radio signals. They might listen for radio signals from us, yet they wouldn't dispatch a spaceship. The energy cost would be excessive. It would make no sense. And even if somehow they did dispatch a spaceship, even if somehow physics laws were incorrect and some loophole exists that I'm unaware of, the spacecraft would arrive here once perhaps in all of human history. Not repeatedly, not so that it leaves physical traces and recordings that we can analyze. Once if this is what I intend, when I state aliens are constrained by physics, they're limited by the identical laws that we are. And those laws aren't favorable to the concept of casual interstellar travel. Now, I want to shift focus slightly because I don't want to leave you with the impression that I don't consider about aliens. I do. I consider about it extensively, actually, because the question of whether life exists elsewhere in the universe is a fascinating question. It's a question about life's nature itself. Here on Earth, life emerges fairly quickly once conditions are appropriate. Earth formed approximately 4.5 billion years ago, and life appeared within the initial 500 million years or so, perhaps even sooner. So it seems like life isn't some incredibly rare accident. It seems like life is something that emerges naturally when you have the appropriate chemical components and the appropriate time duration. Now, those chemical components are everywhere in the universe. Water, organic carbon, nitrogen, phosphorus, all of these elements exist abundantly. They're in interstellar dust. They're in comets. They're probably in numerous planets' atmospheres. And chemistry laws are identical everywhere. So if life emerged on Earth because of chemistry laws and certain molecules availability, then it should emerge on other planets too. It probably has. So I anticipate that intelligent life exists somewhere in the universe, perhaps in numerous locations. Yet I also anticipate that they are very far distant from us. And I anticipate that physics laws prevent them from casually visiting. Those laws are fundamental. They're not negotiable. And here's the aspect that fascinates me about this. It's that even if an alien civilization achieved incredible technological sophistication, even if they harnessed their star's power and understood physics better than we do, they would still confront the identical fundamental problem. They would still be constrained by nature's laws. They cannot escape those laws any more than we can. This is actually one of the most important lessons that physics teaches us. Nature's laws aren't obstacles to be overcome. The game's rules, they apply everywhere. They apply to everything. And understanding those laws and accepting the limitations they impose is essential to understanding what's feasible and what's not. You understand, a tendency exists in people, a very human tendency to imagine that advanced technology can accomplish anything, that if you're intelligent enough, if you're advanced enough, then anything is feasible. Yet that's not how it functions. Advanced technology can accomplish some things better than primitive technology, yet it cannot violate nature's laws. It cannot create energy from nothing. It cannot make matter travel faster than light speed, at least not with any physics we understand. So when I consider about aliens, I consider about this limitation, and I consider it's actually a very fascinating limitation because it informs us something about what we should anticipate to find in the universe. If we ever do find evidence of extraterrestrial intelligence, I would anticipate it to take the form of radio signals, not spacecraft. Radio signals. Because radio communication is inexpensive energy-wise. You can dispatch a signal utilizing far less energy than you would need to dispatch a spaceship. That's the thing we should be searching for. That's the realistic scenario. And if we ever do receive a radio signal from an alien civilization, what a moment that would be. What an incredible moment for science and for humanity. Yet I consider we should be realistic about what that signal would inform us. It would inform us that intelligent life exists elsewhere, yet it wouldn't signify that the aliens are coming to visit. It would merely signify that they are there somewhere far distant, listing like we are attempting to understand the universe. Now, allow me to merely touch on something else because I consider it's important. Some individuals claim that the government understands about aliens and is concealing it. They claim that UFOs exist in secret facilities being reverse engineered by scientists. They claim that the government has made contact with alien civilizations and is maintaining secrecy. And I'm always amazed by these claims because they seem to require more of an explanation than the simplest explanation. You understand, for a secret alien spacecraft to exist in a government facility, an alien spacecraft would first need to exist. And we've already established that the energy cost of getting a spacecraft here is enormous. The probability of that occurring is extremely low. So the claim that the government possesses a spacecraft is less likely than the claim that no aliens are visiting Earth. Also consider it logically. If the government genuinely did possess an alien spacecraft and they genuinely did understand how it functioned, do you consider they would maintain secrecy? They would want to figure out the technology. They would want to understand the propulsion system. They would want to understand the weapons, and that signifies they would need the finest scientists in the world working on it. And if the finest scientists in the world are reverse engineering an alien spacecraft, some of them are going to speak. Some of them are going to publish papers. Some of them are going to share what they understand with others. That's how science functions, and we don't observe that. We don't observe any credible scientific evidence that the government has reverse engineered anything. So I'm skeptical of those claims too. Not because I'm close-minded, yet because I'm paying attention to what would actually occur if those claims were true, and what I would anticipate to observe if they were true. And I don't observe those things. Allow me to step back for a moment and consider about what we should genuinely care about when we consider about aliens and physics and nature's laws. Initially, the question exists of whether life exists elsewhere in the universe. And I consider the answer is probably yes. The universe is immense. Physics and chemistry laws are identical everywhere. Life's components are everywhere. So, life probably exists in numerous locations. That's a reasonable conclusion. I consider second, the question exists of whether we will ever make contact with that life. And I consider the answer is probably no, at least not in the near future. Not unless we figure out how to dispatch radio signals or receive them. And not unless an alien civilization is sufficiently close and sufficiently advanced to do the same. The distances in the universe are enormous. The timescales are enormous. The probability of two civilizations developing at roughly the identical time in roughly the identical place in this immense universe is extremely low. Third, the question exists of how we should consider about limitations in physics. And I consider this is the most important one because understanding limitations is what science is all about. It's about understanding what's feasible and what's not feasible. It's about understanding the game's rules. And once you understand the rules, you can ask better questions. So when you consider about aliens, don't inquire. Are they visiting us? Inquire instead. How would they visit us? What would it cost in energy? What would it require? And is that actually probable? And then you can work from fundamental principles. You can work from physics laws, and you'll discover that the answer is very different than what the flying saucer enthusiasts might suggest. You understand, I've often considered about this question of how to detect an alien civilization if they were attempting to communicate with us. And it's a fascinating problem because it reaches the heart of what you could understand about something if you only had limited information. Envision you're attempting to explain to an alien civilization over the radio what human beings appear like. You cannot dispatch images. You can only dispatch numbers. What would you do? Well, you might begin with basic integers. You might establish a numbering system, and then you might begin to describe size and shape. You might describe a height relative to hydrogen's wavelength, which is identical everywhere in the universe. And then you might reach the tricky part. You might state, now we possess a heart and it's on our body's left side. And the alien inquires, which side is the left side? Now you have a genuine problem. How do you define left and right over the radio? How do you describe your own handedness to something that might have completely different symmetries, completely different biology? And it turns out only one method exists to accomplish it. You must reference a phenomenon that has handedness built into it, a phenomenon where nature's laws themselves prefer one direction over another, and that wasn't understood until 1957. Before that, physicists considered that physics laws were completely symmetric. Left and right were indistinguishable. Yet then a remarkable experiment was performed, and it was discovered that at the subatomic level, at beta decay level, nature does prefer one direction over another. So now you could inform an alien over the radio which direction is left. You would perform an experiment. You would describe the experiment, and you would ask the alien to perform the identical experiment, and they would observe the identical asymmetry that you observe. And from that asymmetry, you could both agree on what left and right signify. This is the kind of problem that would arise if we ever made contact with an alien civilization. And it demonstrates that even the simplest communication would require understanding of fundamental physics. It would require both sides to understand nature's laws in detail. And it would require both sides to be able to perform experiments to verify what they're claiming. So this is another limitation on communication with aliens. It's not a limitation of energy or distance. It's a limitation of what you can meaningfully convey to something that might think completely differently than you do. You would have to find common ground in physics laws themselves. I consider about this often. I consider about what it would signify to have a conversation with an intelligent being that evolved on a different planet in a different solar system under different conditions. What would be identical? What would be different? And I consider the answer is that physics laws would be identical. Chemistry laws would be identical. Yet everything else might be different. Their biology would be different. Their psychology might be different. Their values might be different. Their history would certainly be different. And yet, despite all those differences, you could still have a meaningful conversation because you could reference physics laws. You could both point to the identical physical laws and state, here, this is true. We both understand this is true. Let's build from here. So, in a peculiar way, physics laws are the only universal language. They're the only thing that would be identical across the universe for every civilization, no matter how different they might be. And that's what I intend when I state aliens are constrained by physics. They're not merely limited by physics in practical terms. They cannot easily travel between stars. They cannot construct perpetual motion machines. They cannot obtain free energy from nowhere. They're also limited by physics in a fundamental sense. Their entire understanding of reality is built on physics laws. Their technology is built on physics laws. Their ability to communicate across the stars would have to be grounded in physics laws. So when I consider about aliens, I don't consider of them as beings who have somehow transcended nature's laws. I consider of them as beings who, like us, are limited by those laws, and that limitation is actually what makes them comprehensible. That's what makes it possible to consider about them in the first place. Because if physics laws were different for them, if they obeyed a different set of rules than we do, then we couldn't predict anything about them. We couldn't state whether they could construct spacecraft or dispatch signals or accomplish anything else. We would have no method to consider about them at all. Yet because we share identical physics laws, we can make predictions. We can state if an advanced civilization exists, and if they want to communicate with us across the vastness of space, then they would probably use radio signals, because radio signals are the most energy efficient method to dispatch information across vast distances. We can reason about them. We can consider about what they might do and why they might do it. So physics laws, in a sense, are the key to understanding anything about aliens at all. And if you accept that physics laws apply to them as well as to us, then you're forced to conclude that casual interstellar travel is probably not feasible, that visiting Earth would be an incredibly expensive undertaking, that it would only occur for the most serious reasons, and that it probably hasn't occurred at all. This is not a limitation. It's not a sorrowful conclusion. It's actually a liberating conclusion in a way, because it signifies that we don't have to worry about being invaded by aliens. We don't have to fear that our planet is being secretly visited and monitored. We can focus on the genuine questions. We can focus on whether life exists elsewhere. We can focus on how to detect it if it does. We can focus on understanding physics laws better, and that's really what it's all about. Understanding nature's laws, accepting the limitations that those laws impose, and working within those limitations to figure out what's genuinely feasible. You understand, I consider the finest method to conclude. This is to return to the beginning, to return to that conversation about flying saucers that I had numerous years ago. Someone asked me, is it impossible that flying saucers exist? And the answer is no, it's not impossible. Nothing is absolutely impossible. Some probability always exists, however small, that something could occur. Yet that's not genuinely the useful question. The useful question is, how probable is it? And what would it require, and does that requirement make sense? And when you ask those questions, when you genuinely consider about the energy costs, the distance problems, the probability calculations, you recognize that casual alien visitation to Earth is incredibly improbable. So improbable that you're probably wasting your time searching for evidence of it. Yet the search for other life in the universe, that's not a waste of time, that's a noble endeavor. That's something worth doing because it informs us about ourselves. It informs us about life's nature. It informs us about the universe. And understanding physics laws, understanding how those laws limit what's feasible and what's not. That's not limiting, that's empowering because it provides you the tools to think clearly about the world. So remember this, aliens, if they exist, are constrained by physics just like we are, and that's not a limitation. It's a reminder of what we all share.